In this video, we will be discussing Parkinson's disease, a progressive neurological disease. Symptoms of the disease are mainly physical, including tremors, bradykinesia, stooped posture, and a shuffling gait. However, the pathology of Parkinson's disease originates in the brain. Parkinson's disease affects a part of the basal ganglia known as the substantia nigra. In this model, the substantia nigra is shown in black. Normally, the substantia nigra produces dopamine, a neurotransmitter that is transmitted to the striatum, another component of the basal ganglia that facilitates voluntary movement. The striatum is shown in light blue in this model. In Parkinson's disease, the substantia nigra degenerates over time, causing less dopamine to be transmitted to the striatum. And, as the disease progresses, the amount of dopamine reaching the striatum decreases gradually, causing the movement disorders typical of Parkinson's. In this model, the substantia nigra is represented by the white rectangle with the black border. The blue rectangle represents the striatum. We can see the black neuron carrying the purple dopamine to the striatum. The release of dopamine is balanced by the release of acetylcholine, shown here in pale blue. As the substantia nigra degrades, the amount of dopamine is reduced. This imbalance of dopamine and acetylcholine results in the physical signs and symptoms of the disease. Treatment of the disease is primarily pharmacological and aims to restore the balance of dopamine and acetylcholine in the striatum. Because dopamine cannot cross the blood-brain barrier, the primary treatment of Parkinson's is with levodopa, a precursor to dopamine that can cross the blood-brain barrier. Once the levodopa has crossed the blood-brain barrier, it is metabolized into dopamine. This is done by dopamine carboxylase. However, dopamine carboxylase is also present in the rest of the body. To prevent the levodopa from metabolizing prematurely, it is paired with carbidopa. Carbidopa essentially protects the levodopa from dopamine carboxylase until it enters the blood-brain barrier.
Dopamine carboxylase is here. The carbidopa protects the levodopa. The levodopa crosses the blood-brain barrier.
Dopamine agonists, which mimic the function of dopamine, can be added to a pharmacological regimen that includes levodopa and carbidopa. Anticholinergics may also be useful. These medications function by blocking cholinergic receptors to restore a balance of dopamine and acetylcholine. Finally, MAOB and COMT inhibitors may reduce the degradation of available dopamine in advanced cases of Parkinson's.